Welcome to this course on fundamentals of electric vehicles and renewable energy. And let me start with an overview of electric vehicles. This will give you an understanding of what the electric vehicles are, how different they are from petrol vehicles, and what are the key concerns. And as I mentioned in the introduction, I will divide into two parts, 1A and 1B, where 1A is going to be the introduction to electric vehicles, how does it really differ from a petrol or ICE vehicles, whereas 1B is going to talk a little bit in terms of policy and economics in context of India. So let me start with the basic introduction. Let us see what the drivetrain of electric vehicle look like. Basically, of any vehicle, petrol vehicle, this is particularly a petrol vehicle, electric vehicle is similar. The key thing is a fuel tank and engine, and of course then there is the whole traction. This engine will drive and there will be gears, wheels and everything, and fuel tank is where you will store the fuel, you will draw the fuel out into the engine and you will drive it. What are the key things that we have to all the time worry about? There are two parameters called torque and speed. Torque actually is the force, the angular force that the vehicle will have, and speed of course is the speed, and power is equal to torque into speed. So, this is a very fundamental equation, and all you have to worry about what therefore the engine torque, whatever is the torque of that the vehicle has to face, and what is the speed at which you have to do, and you have to provide that much power, and engine will provide the power taking petrol from the fuel tank, petrol or diesel. And there is this petrol injection pipe from fuel tank to engine, and you can increase decrease amount of petrol that you can take, and by increasing or decreasing the petrol you are able to change the speed and the torque. Of course, you'll have an accelerator which will say now I want to increase the speed, and it will start drawing more energy from the fuel tank. Of course, to decrease the speed you will use brakes. The torque per se will be what the road offers, and you will have to generate enough power to overcome that torque. So, this are the basic drivetrain. Besides this, a very important component in every vehicle is either hydraulics or battery electricity. There are two kinds of vehicles. Conventional vehicles always had hydraulics. Now, what is hydraulics? Basically, the rotating motion is captured to provide what is called power brakes, power steering and air conditioning. This it is what you did, hydraulics will actually convert the rotary motion that the engine will provide into another speed, another torque, and that used to be done by hydraulics. Today, and power brakes, power steering and air conditioners play a very important role in the vehicle, and these three, the power comes from petrol drives the engine then drives what is called hydraulics, and hydraulics will then drive power brakes, power steering and air conditioner. This was the conventional. More recently, the power brakes, power steering and air conditioner were the first ones to be electrified. So, power brakes today that in the new vehicles that you have are the ones which uses electricity. Similarly, power brakes, power steering uses electricity and air conditioner uses electricity. Now, essentially this will come from electricity will come from some kind of battery. So, in the first case, in conventional case, engine shaft is connected to, in the second case, engine shaft is connected to a dynamometer. A dynamometer will convert a motion into electricity, and this electricity is what is used for auxiliary power, including for electronics, for any communication, sensors and light, and it will charge a small battery, and that power from the small battery could drive power brakes, power steering, even the air conditioner in if a dynamometer is put. Alternatively, of course, all this can be driven, of course, the electronics and communication and lights and sensors will always require electric power. Hydraulics alone will not be enough, but other things like power brakes, power steering and air conditioner will always could be driven either by hydraulics or electric power. Now, what happens is that since there is a dynamometer and you are anyway converting the rotary motion which is provided by the engine into electricity and storing it in the battery, you can also have the battery drive some kind of a motor which can assist your otherwise engine. So, you have two drives, one is a petrol driven, another is a electric. So, this is a what is called mild hybrid. This is the very early starting of electric vehicles, not really electric vehicles, but electric vehicle part of it motor is assisting. So, that kind of are called mild hybrids. We will not discuss the various mild hybrids and all that, but that is what is done. Of course, the other sort of said that the engine shaft to drive hydraulics for auxiliary power. So, these are all power brakes, power steering, air conditioner, and today more and more electronics, communication, sensors and lights are all auxiliary power. One point that I want to make, I think many of you already know that the electronics, communication, sensors and lights take very small amount of power, very, very small amount of power. Whereas, of course, air conditioner will take major amount of power, and similarly power brakes and power steering do take considerable amount of power. These are requires very little. There is one more concept that has started coming in petrol vehicles in last 7-8 years, what is called regeneration. Now, what is this regeneration? Basically, if you are decelerating, now why are you decelerating? By using brakes and things like that, you are decelerating because you want to stop the car, or when you are driving down you want to decelerate because vehicle is anyway going to accelerate and you want to decelerate. Now, when you want to decelerate, conventionally earlier what you used to do, there used to be the mechanical brake which essentially will try to stop the tires from rotating, it will slow it down, and the rotating tires engine used to be converted through friction into heat and used to be dissipated. So, that much energy was lost. Every time you applied a brake in a conventional vehicle, the energy will be lost. Similarly, if you are climbing up, you require a lot of energy. When you try to climb down, energy you will have to apply a brake and energy will be lost. Now, what has happened is that instead of that, the brakes are changing into what is called electronic brakes, electrical brakes. So, here in fact, instead of friction energy, you try to kind of use some kind of a motor to drive the tire back. You slow down using some kind of a motor. Essentially, or instead of some kind of motor, you actually use what is called a generator. So, you try to convert the deceleration power into so you try to rotate the generator the other way around, and in the process the electricity is produced. That electricity can be stored into battery and that can save your fuel, because you had accelerated or you had climbed up and you used a lot of fuel, while climbing down or decelerating you can save the fuel. So, this the mild hybrids are all related to that. The final thing that is required in a petrol vehicle is a petrol pump. You go to a petrol pump whenever your fuel tank is empty and you actually put fuel. So, publicly available fuel petrol pumps are required for the vehicles to move, and this is what has been happening for I do not know how long, over 100 years, and I think all of you know a lot about these vehicles, petrol or diesel vehicles. Now, what has changed recently? Of course, you will see a small amount of electric part entering out here, but fundamentally they still remain petrol vehicles, because the main fuel came from petrol or diesel. What has changed? And let us look at what has changed. So, what I will do is I will put on one side petrol vehicle, another side electric vehicle, and say what is replacing what. So, there was this engine and engine control. Remember the engine control by actually controlling the amount of fuel that goes in, and of course, accelerator and brakes. Today, that is being replaced by motor and controller. So, the most important thing, engine will go away and motor and controller will. Engine and engine control goes away and motor and motor controller comes. So, very important. The second change is, there was used to be fuel tank plus of course petrol, diesel, whatever, and petrol injection pipe. This you could control the amount of fuel going in, and more fuel would be required if you are accelerating, going at higher speed. Less fuel is required if you are not accelerating. In this case, the fuel tank is same as a battery. Battery is fuel tank is what? Stores petrol. Battery stores electrical energy. So, fuel tank equivalent to fuel tank is a battery, and we will talk about the difference also later on in detail, because fuel tank is inexpensive, battery is very expensive. Fuel tank, you put it once, pretty much stays through the life of the vehicle. Battery is a storage of electricity, and it will, after some time, the storage keeps on reducing, and then you replace the battery. Fuel tank, you can put the fuel very fast. Battery, depending on the rate at which you put in electrical energy, the battery will deteriorate faster or slower. We will talk about all these things going forward. But of course, the major energy that is used in petrol vehicle is petrol or diesel, whereas it is electricity. And in this case, petrol injection pipe is controlled by the fuel tank and petrol, and more or less petrol is taken and goes to the engine. In this case, what you will control is current, more current or less current you will draw. If you draw more, if you are accelerating, you will draw more current. If you are climbing up, you will draw more current. If you are not, you will draw less current. So, current control becomes very, this controls the drive. So, this is the difference between petrol vehicle and electric vehicle. Then, as I mentioned, conventional vehicle has this hydraulic, an engine drives hydraulic for auxiliary power, and alternatively you can have a dynamometer which is charges electrical battery, and this will give you all the power required for brakes, power steering, air conditioners, or all other auxiliary power. In this, the power is already electricity, battery already have electricity. So, you do not need another battery. However, battery will typically be at a different voltage. Battery will be high voltage, could be a 48 volt, could be 350 volt, could be 750 volts, and we will discuss all of this. Whereas, auxiliary power may require smaller voltage, 12 volt, 5 volt, lights may require even less. So, you use what is called DC-DC converter. The battery has a DC power output, you convert, a converter will convert it to from 48 volt to 12 volt or 350 volt to 12 volt. And then maybe you will use this 12 volt or sometime 24 volt, sometime even 5 volt for power brakes, steering, air conditioners and all electronics, communication, sensors, etc., etc. So, this hydraulics gets replaced by a DC-DC converter. DC-DC converter are very low cost, small devices, it is an electronic circuit, but that is what is used. And finally, while in a petrol vehicle you have to go to a petrol pump to fill the petrol tank, in a electric vehicles you will go to a battery charger, you will need to go to a battery charger, and that will fill the electricity in the battery. Okay. We will talk about the difference between a petrol tank and a battery chargers. Charging becomes a very important component, because the characteristics of battery in one way is very different from the petrol tank, even though the two are playing the same role. Okay. Interrupt me if you have questions and we will answer that. Raise your hand. And regeneration. Regeneration I mentioned, you are basically recovering energy during deceleration, during climbing down. That is there. It was not there in your conventional petrol vehicles, but recent petrol vehicles have started to do that. And of course, regeneration is key to electric vehicles, because you will not waste energy. You have a battery already, you will, whenever you are decelerating, you will use the motor itself as a dynamometer, create the electricity and put it back into the battery. That becomes a very important component. Regeneration becomes a very important component. So, I have already done that, but let me summarize therefore. So, what is replacing? The basic vehicle is same, tires and body and everything, axles and all those things. But instead of a petrol engine, it is electric motor which drives this. An electric motor has an important component called controller, which is like your fuel pipe injection, and then there is a battery. Controller will draw more or less current from the battery and drive the electric motor and do this. Once again, power is equal to torque into speed, no difference. The battery plus electricity, current of battery drives more or less energy in motors, and the important component, there is a power, current and voltage. Power is voltage into current. Voltage is more or less fixed, could be around 48 volt. Of course, it is not really fixed, that 48 volt may itself varies from around 56 volt to 43 volt, or similarly 350 volt may vary all the way from 370 to 330 volt. That depends on how full the battery is. If the battery is full, the voltage is higher. As the battery becomes less full, the voltage goes down. But typically it is around that 48 volt or 350 volt or 750 volt. It is the current which you draw more or less, and power is equal to the voltage into current. Of course, almost everybody knows. And as I pointed out, there are DC-DC converters, converts the battery voltage to the desired voltage. As I pointed out, the voltages that are required are 12 volts typically, sometimes 24 volts, 5 volt, 3.3 volt, all these converters are there, electronic converters, electrical circuits, these are done. And deceleration during deceleration, regeneration during deceleration and climbing down. So, essentially motor acts as a generator. This will be covered well by Kannan when he talks about motor, how it can also act as a regenerator. So, that is a very big plus, we can straight away do that, we do not need extra thing. Remember, therefore, hybrid vehicle is a petrol vehicle plus elements of electric vehicles are getting added. So, hybrid vehicle will be invariably higher cost. It will never have the efficiency of electric vehicles. So, it is a extra cost. Of course, it will save some fuel. So, instead of, let us say what 10 kilometers per liter or 12 kilometers per liter, now you may get 16 kilometers per liter depending on your vehicle, but it is essentially a petrol vehicle. Whereas in this case, all the energy you attempt to try to recover. and of course battery chargers. Petrol pumps are replaced by battery chargers, and we will talk about what the chargers are, where the chargers need to be placed. So, this is basically the difference between electric vehicle and a petrol vehicle.